Welcome to section 5.1. This is the first chapter in the last unit that we have to do in our class, and it's going to be concerned with prime numbers as we look in section 5.1, and then we'll expand that view. Prime numbers have a lot of uses in mathematics, so we want you to be aware of them, and some of those we'll see as we navigate through chapter 5. And so let's give you a definition of a prime number. So a prime number is a number that can only be factored as 1 times itself. Okay, so we're thinking about just kind of broad factors here, integer types of factors. So for example, the number 12. Is the number 12 a prime number? So is 12 prime? The answer to that is no, and the reason is 12 can be written as 2 times 6, which is not 1 times itself. Now it can be written as 1 times itself, but because it can be written a second way, and even a third way, but really just because of the second way, it is not prime, because a prime number can only be factored as 1 times itself. So let's get you an example of a prime number. So let's come back in here and let's get rid of the 12 and let's do a number like 11. A number really close to 12. Is 11 prime? Let's think about 11. 11 can definitely be written as 1 times 11, as everything can, 1 times itself. So is there anything else? 2 doesn't go into it, 3 doesn't go into it, 4 doesn't go into it, 5 doesn't, and then at that point we would loop ourselves, and so 11 is an example of a prime number. So as we start to think about the primes, the one number that they will not consider to be prime or composite is 1. So we should note that the number 1 is special. It is neither prime, which you have a definition of, or composite. So they'll use this word composite. A composite number is a non-prime number, a number that has other breakdowns than 1 times itself. So lots of numbers are composite. Most of the numbers we see are composite, but there's some primes scattered throughout there. But 1 is neither considered prime nor composite. So if we start to list out the primes, and we start at the lowest one, 2 is the lowest prime number. 3 can also only be written as 1 times itself. So if we think of the next number 4, well, we can't include 4 because 4 is 2 times 2. But 5 can be included. 6, no, that's 2 times 3. 6 should not be included. I said no and then I wrote it. Okay, 6 is not included, but 7 is. Not 8, because 8 is 2 times 4. Not 9, because 9 can be written as 3 times 3. Not 10, because that's 2 times 5. But 11 we saw was. 12 isn't. 13 is. 14 is not. So we can start to skip the even numbers, because every even number is going to be divisible by 2. And so the only even prime is number 2. Everything else would have a factor of 2 in it, in addition to something else. So if I just think about odds, 15, nope, that's 3 times 5. 17, yeah. 19, yeah. Not 21, because that's 3 times 7, but 23. Not 25, because that's 5 times 5. 27 is 3 times 9. But 29 is. And we would just keep going like that. So there's an infinite number of primes. They'll probably be considered on the lower end of them in terms of our focus. However, I know that the next section deals with some large primes, but we're discovering those primes as opposed to trying to figure out if it is prime or not. And so the homework for this section is going to ask you about prime numbers and decide whether number's prime or composite. It's also going to say give all the factors. So give all the factors of, and let's do a couple at least, of a number like 24. Okay, so when they want all the factors of them, they're looking for every number that divides evenly into 24. So 1's always going to be a factor of every number. Then you would just go piece by piece. Does 2 go into 24? Yes, because it's even. 3 does as well because it's in the realm of our memorization. 6 times 4 is 24. And maybe that's the way to do it. Maybe a good suggestion would be, hey, 1 and 24 works. 2 times 12 works. 3 times 8 works. 4 times 6. Not 5, and then we're back up to 6. So here's all your factors. They come in pairs, right? Each one paired up in order to get you to 24. So if we do the same thing with a bigger number, maybe something like 300, we know 1 goes in there and is matched with 300. We know 2 goes in there 150 times, right? And you can grab a calculator. 3 definitely goes in there 100 times. I don't know about 4, right? And so 4 should go in there. So let's talk about 4. We know 2 goes in there. And when divided by 2, it was 150. 150 is also prime. So, 150 is also even. So another 2 would go in there. So 4 will go in there because 2, well, I guess I'll show you what I mean. 300 divided by 2 was 150. We can divide by 2 again, which is the 4 for 75. So a 4 and a 75. A 5 definitely works. And you see, I didn't leave myself a lot of space, or enough space. 5 goes in there 60 times. 6 goes in there, right, 50 times. So we get a 6 and a 50. 7, probably not, but we got to try 7. There's no divisibility rule for 7. 7 times 4 is 28. And no, 7's not going to go in there. 8, 8 might, but I don't think so. And here's the reason why I don't think so. When we did the 4, we got a 75. We would need one more 2 to go in there. So 300 divided in half is 150. Divided in half is 75. 8 won't go in there. 9, I don't think 9's going to go in there. 9 going into 300. 3 times for 27. Yeah, we're going to get a bunch of 3's repeating. 10 does, though. 10 goes in there 30 times. Okay, and that's what we have to do, is just keep going forward. 11 most likely won't go in there. 11 into 300. 2 for 22. Get a remainder of 8. Yeah, 11's not going in there. 12? Let's think about that. Would 12 go in there? Well, we already know 3 goes in there and 4 goes in there, so 12 will go in there. And so if the factoring pieces of 12 go in, then the whole thing will go in. And so you're just going through this big process. So let's see how many times 12 goes in there. 12 times 2 is 24. And 12 times 5, so it's a 12 and a 25. 13, no. 14, nope, because 7 didn't go in. 14 can't go in. 15, yep, 15 should go in because a 3 and a 5 go in. And what you'll see is that we're getting closer and closer to, 15 and 20. We're getting closer and closer to each other. 16 won't go in because 8 didn't. 17 won't go in. 18, 18's made up of a 2 and a 9, but the 9 didn't go in, and so 18 has no chance. And then 19, no, and 20 we've looped back. So there's all of our factors. If we were to list them out in order, it would be 1, 2, 3, 4, 5, 6, 10, 12, 15, and then it would be 20, 25, 30. And I specifically picked something that would have a lot of factors just to give you the worst case scenario. So let's take a moment to step back about what we did. And then what we did will be the other pieces of this. The first thing I did was I started small. And so we want to make sure that you're well aware of the divisibility rules. For the following. A. 2. The divisibility rule for 2 is if the number is even, it is divisible by 2. If it ends in 0, 2, 4, 6, or 8, it is divisible by 2. Anything like that, we would know it's divisible by 2. So when we looked at 300 and also 24, both of those numbers were divisible by 2 because they were even in nature. They ended in a 0 in one case and a 4 in the other. So if it ends in 0, 2, 4, 6, or 8, it's definitely going to be divisible by 2, and we should take the time to do that. A number is divisible by 3 if the sum of the digits is divisible by 3. So take a look at the two numbers that we had. We had the number 24 and we had the number 300. If we wanted to know if they were divisible by 3, what this is trying to say is 24 is divisible by 3 if 2 plus 4 is. Well, 2 plus 4 is 6. 6 is divisible by 3, so therefore 24 is divisible by 3. It doesn't tell you what the answer is. It just tells you it's worth your effort. Same thing here. 3 plus 0 plus 0 is 3. And 3 is divisible by 3. And so 300 is divisible by 3. And then we can find out, oh, that's 8. Oh, that's 100. And we may have already known that. But what we might not know is if we had a number like this, 1551. Is that divisible by 3? Nothing really about it tells me that it is. But if I add up the digits, if I add up 1 plus 5 plus 5 plus 1, I get 12. And 12 is divisible by 3. So therefore, 1551 will be divisible by 3. 3 will go in evenly. And we can see what would happen there. 5 times 3 is 15. 1 times 3 is 3. And 7 times 3 is 21. So it's the 1551 divided by 3 is 517. So there's some nice divisibility rules that can help us out. There's one more that we should cover that you're probably already aware of. Let me get rid of this. This was just an example of the divisibility rule of 3. Do not apply the divisibility rule for 3 to any other number. It doesn't work for 7 or anything like that. It only works for 3. Just like ending in 2, 4, 0, 2, 4, 6, or 8 only works for 2. And so you just kind of compartmentalize. Unfortunately, there's no divisibility rule for like 7. You just have to try it. There's been none that have been shown to be super effective other than just trying it. 5's the other easy one. If it ends in 0 or 5, it's divisible by 5. And so, for example, 24 was not divisible by 5, and we never listed it, but 300 was because it ended in a 0. And so they'll have some questions in which you decide whether something is divisible by 2, 3, or 5, or even other numbers. So, but we'll focus on 2, 3, and 5 for right now. So if we had a number like 2, 1, 3, 5, 0. This number we could easily see it's divisible by 2. And so divisible, I'll write it out, by 2. Absolutely. We can quickly see that it's divisible by 5. Because it ends in a 0, it's divisible by 2. Because it ends in a 0, it's also divisible by 5, meaning 5 will go in evenly to that number, and so will 2. We still have to do that, right, if they wanted us, but sometimes they're just wanting us to know whether it's divisible by those numbers. Now, what about 3? Is it divisible by 3? What's 2 plus 1 plus 3 plus 5 plus 0? Well, that's 5, 6, 7, 8, 9, 10, 11. That is equal to 11. 11 is not divisible by 3. So therefore, 2, 1, 3, 5, 0 is not divisible by 3. And only these two, if those are the two that are asking about. So occasionally they'll ask you about a number and whether it's divisible by a composite. And I modeled this a little bit earlier as we were looking at the number 300. going to bring back 300. Sometimes they'll ask you, hey, is this divisible by 6? Is a number divisible by 6? So if I looked at something like 3, 1, 2. Well, let me not do that, because that's pretty obvious that that would be divisible by 6. Let's take a look at something like 1, 5, 1, 2. Okay, maybe that's equally as easy to see. Or maybe this. Well, let's leave it like that. 1, 5, 1, 2. Obviously, this is divisible by 2, right? So it's divisible by 2. And if we look at it and add up the digits, 5 plus 1 is 6, plus 1 is 7, plus 2 is 9. So the sum of the digits is 9. And 9 is divisible by 3. So it's also divisible by 3. So it's divisible by 2, it's divisible by 3. Therefore, it's divisible by the product of those. So if you ever want to know if 6 goes into a number, you know automatically 6 will go in if 2 and 3 go in. So earlier when I was dealing with 300, I was wondering about a number like 12. And the way I figured out 12 would work is because 3 went in and 4 went in, 12 had to go in. When I thought about 15, 3 went in, and 5 went in, so 15 has to. And that's how you check for the composite. So if they ever ask for a composite and say, hey, is this number divisible by 9, by 10, by 12, just see if their parts are there in the ones that you've done previous. And you'll see that as you go through the homework. It's actually pretty nice. The last things that they're going to be asking you to do is prime factorize a number. So they're going to give you a pretty big composite, maybe like 2820. And the best way to prime factorize a number is through what we call a factor tree. It's not the only way, and so if you've learned another way, you might feel that's the best, but they focus on the factor tree. When you do a factor tree, you can choose any factorization you want, whatever you see. So somebody's going to look at this and say, you know what, 2820 is divisible by 2. And they're going to write a 2 and write a 1410. Okay, and they're right. Somebody else is going to look at 2820, and let me give myself some space as much as I can. They're going to look at 2820, right, that's the same number, and they're going to say, you know what, 10 goes into that number. So there's nothing magical to pick. You don't have to pick a composite or a prime. You can pick whatever breakdown you want. So let's continue with this one. Any breakdown. So 1410 divisible by 2. Now I circled the 2 because the 2 doesn't break down anymore. I should have explained that. If I try to break down 2, can't do it. It's prime. So I circle it. 1410, definitely divisible by 2. I get 705. How about 705? What's something you know goes into that? Well, 5 does, and 5's prime, so I'm going to circle it. Now, I don't know how many times 5 goes into 705, so let's find out. 1, 5, 2, 0, 4. So you're going to have to do, I guess you have a calculator. You could do it that way. 141. Now, how about 141? Does 141 break down? Well, it's definitely not divisible by 2, and it's not divisible by 5. Another quick one to check is 3. How about 1 plus 4 plus 1? What is that total? Well, a total 6. And so 6 is divisible by 3, so 141 is. So we're going to take 3 into 141. And 3 goes into 14. 3 times 4 gets me close to 12. And we get a 47. Now let's think about 47. I don't think 47 can be broken down. I think it's prime. It's definitely not divisible by 2, 3, 5, no. 9 times 5 is pretty close. My smoke alarm's going to go off here in a minute. 9 times 5 is pretty close, but not there. 6 doesn't go in there. 7 doesn't go in there. I think it's prime. So the prime factorization is 2 times 2 times 5. Actually, they typically list them out in order. So 2 times 2 times 3 times 5 times 47. Or sometimes they'll write it as 2 squared times 3 times 5 times 47. That's the prime factorization. We should get the same thing here. As we get to 2820, we broke it down to 10 and 282. As we ask ourselves, does 10 break down? Yes, into 2 times 5. So we didn't immediately circle it because it was on the left. We were circling only the prime numbers. How about 282? 2 goes in there 141 times. And we found out that 3 times 47 was what gave us that. And so you can see that we get the same 2 times 2 times 3 times 5 times 47, no matter how we cut it. And so the last part of the homework is doing this factor tree to break everything down into a product of only primes. And there's reasons for that. There's uses to have a prime factorization. And I think they'll show us that later in 5. They just want us to build up the skill set here in 5.1. All right, enjoy the homework, but let me know if there's questions as you go through it.